My name is Alexander Engels. I live actually and work in Slovenia for now 5 years. Next week, exactly 5 years. So yes, I understand a little bit of Slovene. No, nobody wants to hear me talking Slovene, because that's a safe choice to get everyone out of the room. All right, so not that I'm only living and working here. A couple of years back, I co-founded a company called Solopex. And with this company, we're working on the digital side of the fourth industrial revolution. So, and we work with customers, obviously in Slovenia, but also back in Germany. And these customers typically come from, well, nowadays from automotive, from steel industry, or from industrial manufacturing. More specifically, what we do there is we combine mathematics, computer science, and engineering to develop products and services for planning automation, for the system design of Industry 4.0 systems, which is related to this planning automation. And then we combine both parts for smart factory applications. So, broad sense of Industry 4.0. And this broad application brings us in touch with a lot of the underlying technology and applications. And what I'm going to talk about now here, I do not think that this is written in any book, so this really comes from practice. All right, so I want to start with this question. What has changed? Because when I think 10 to 15 years back, well, when I was actually still at university, 15 years, engineers were focusing on optimizing their machinery, so bringing it really down to the 98 or 100% of the machine technology. Computer scientists were working on algorithms, on databases, and mathematicians, at least as when they were applied mathematicians, were working on problems in telecommunications, logistics, or the financial sector. So, and then within, let's say, 10 years, the whole focus shifted from these topics towards the industrial sector. So, what has changed there that this huge shift happened? Of course, technology dropped in. But technology is never the driver of change, it's an enabler. So the change lays somewhere else. And well, my theory is that what really has changed is us. So you, me, and all the people out there in their role as consumers. So this is what I consider the consumer 4.0. And you might see yourself in this description here. I will tell it from my perspective. So if I want to buy something, to purchase something, let's say for my private life or for the company, it doesn't matter. So whenever I have to take this decision, whatever I buy has to be up to date. And how do I know what is up to date? Well, I got told by Facebook, LinkedIn, YouTube, Instagram, you name it. So they are setting, or actually people are setting the trends there and say what's up to date. But still, if I purchase something, I want to express some of my uniqueness. So even though it's like a mainstream thing, I still want to be unique. What does that mean? So if I buy a car, I'm actually pretty used to go to the configurator online and I choose the tires, I choose the colors, so whatever. I have 2 pairs of shoes at home where, well, the one with the 3 stripes, so you can select the color of the stripes, you can select the laces, I even have my name written here on it. So there's this opportunity to have mainstream, to be up to date, and still to be unique, so to be individual. Okay, so we got really used to individualization of our products. On the other hand, if we decide for something, let's say on a Wednesday evening, then we also expect that whatever we decided for is delivered on Friday, and if we don't like it, or if it's not our size, we will send it back by Saturday. So if you just think 15 years back, that was not normal at that time, right? So you just took a decision by going somewhere, you were checking the products, and once you made the decision, you stayed with it. Well, that has changed. But that also has a huge impact to the supply side, and the supply side, these are the manufacturers, these are the producers. So if we translate this here into their world, the upper part here basically means that we expect flexibility from the manufacturers. So flexibility and product variation, and also product quantity. So we want to have it right away. It's not possible, actually, that they have 0 stock and first produce it. And secondly, if we want to enjoy the second sentence here, so to have it really as fast as possible, and of course, also for a reasonable price, this means efficiency. So now these two together are actually the nightmare for manufacturers. Because just imagine, if you want to be highly efficient as a producer of a product, and let's say you have 100 different products in your spectrum, you would choose the simplest one that you can do, and just produce it one after the other, because like this you can do it the fastest way and the cheapest way. But that doesn't get along with the flexibility, so with the individuality that your customers or that the market wants to have. And if you want to be highly flexible, you need the time to rechange your machines all the time to produce a different product. So those two together, that's a traditional or a classical trade-off situation. Now this is actually where Industry 4.0 drops in, because one of the big promises of Industry 4.0 is highest flexibility of the production and your product portfolio, and at the same time to even improve efficiency. All right, how shall that be possible? Well, obviously with a lot of technology that drops in there. But I do not want to go into technology yet. I would like to keep it at two general principles that define Industry 4.0 from my point of view. First one is this here. So while before everything was concentrated on the manufacturing technology, that's what I said, right? So really the hardware, you were tweaking it down to the optimum. The whole thing has shifted now towards data applications. And not only to collect the data and to store it, but also to use this huge amounts of data, called big data, to process it, to gain insights, and to use these insights to improve the overall system. So that's the first, I would call it, disruptive shift, and that's a shift in domain. So from the mechanical or physical part to the digital or logical part. Second thing is a paradigm change. So years back and still nowadays, if you go to bigger factories, and we have seen and heard that before, the traditional organization would be that if that's a very complex system, you would put it into smaller parts that are somehow handleable, kind of divide and conquer. So, but with this, this reduces already the focus, let's say, for sure on several departments, for sure on machine groups or even different machine technologies. So let's say a focused view. But nowadays, with all this data around, and if you're collecting and putting data together from everywhere, well, that gets a system character, and you consider the whole thing as a connected system. And you can imagine that if you change the focus from something very narrow to something very broad, that the whole world changes around that. All right, in the end, and we've seen this already here at the last presentation, so the concept of the new Yaskawa factory, in the end, you would even connect not only the shop floor or the production part, but all the other departments and entities of the company as well. So purchase for sure, sales, logistics, product portfolio, everything all together organized, and the digital technology is the glue that puts this together into one operating system unit. Okay, what technology is here the glue? And I do not want to go now too detailed into it, but I will name now a couple of digital technologies that are around there. It's important here to understand that this technology, again, this is only the enabler for a kind of use case that you're driving with it. And I want to give a kind of scheme here which makes it a little bit simpler, also if you're not an expert, to somehow put it into the categories. And I will do it according to this scheme here. That's a functional scheme, and this relates to the, well, classical system control loop. For the engineers amongst you, so this is a closed system control loop. Every engineer basically at one point in the curriculum has this at university. So every complex system, no matter which system, works according to these 4 steps. Actually 5 with the arrow back. First one is the system has to be planned. So out of this plan, it evolves an execution scheme. So let's say for a production company, this is the working orders. They're giving down, and then they're executed. So whatever is executed there is then tracked or observed. This observation is then compared to the initial plan, and if you see a gap that gets too wide, you go back to the planning stage and readapt. So this is like input, output, comparison, back. And that's the loop that every system has to go through. And then it's just a question if this is done once per day or once per second. Doesn't matter. Every system works that way. So now technology drops into these functions like that. First one, the planning stage. If we consider now this whole connected system and you want to plan it as a whole, so with all the departments, with all the functions, that's an extremely complex task, and this is for sure where artificial intelligence is needed. Not the old algorithms anymore, but really a new kind of composition of digital intelligence to make that work. And cloud computing, well, I know how many people stand on cloud. So the buzzword here would be security and so on. But basically AI and cloud computing you cannot really decouple. If you want to make use of the most powerful algorithms that are available, you need the cloud as a scalable and powerful infrastructure. So now the plan is generated and it comes to execution. So here it depends a little bit on how the shop floor looks like. For the ones that are very evolved and are working with a lot of robots, well then this plan is directly transmitted to the robot and the robot will execute it. But I mean, how many companies look that way, that there's only robots? Most of them will still have a huge proportion of people working there. So, but also here, digital technology can help to increase the information flow and they could give them the right instructions at the right point. What I want to refer here to is mobile apps and then even wearables, which is, I think, a pretty cool way to make use of mobile apps to give this information. So what is shown here is this wristwatch that you can have and which practically substitutes the terminal or something. So mobile apps, if they're used as a feedback mechanism or a feedback tool, so the people would also put in how they're standing on their execution, then it's already the first step into the observation part. And if people are not trustworthy because maybe they pressed the wrong button or whatever, we would probably put IoT sensors here. So directly to the machines or directly to the spots where we could measure what is going on down there, in this case on the shop floor. And again, we are going to need cloud because now we are acquiring tons of data. So this will not fit on a traditional hard drive or a computer. So naturally, it will have to go on cloud as well. I think tomorrow or today we hear something about blockchain, right? So tomorrow, I hear. I'm really not an expert on blockchain. And to be very honest, I do not have this killer application in Industry 4.0 right in front of my eyes yet, but I would put it somewhere here in the observation phase. And tomorrow, then the experts can somehow tell me why this is wrong or why this is right. And the last stage, comparison, this includes then all the technology about data analytics and data evaluation, insights generation. So namely analytics, machine learning, process mining. So with this scheme here, whenever you think from the practical side, how you would organize a system, I hope that this gives you somehow a pointed direction into what digital technology is interesting to look in. And on the other way, if you hear about the digital technology, you might get a picture, okay, where could I use this in practical systems? All right, so now we have it together. Why are we doing this Industry 4.0 thing? What's the driver here? We know a little bit about the technology. Now the next natural question would be, okay, how do we get started? And this point splits up into two key questions. First one is, how do we find a good starting use case? Or let's call it an entry point. So where's the most valuable point where you could start a whole transformation process? And once this is identified, then the second big question, and this is basically present here the whole day already, how do we engage people? So what do we do with people? How do we engage in the process? How do we make them work with this new technology? And here, well, I have a time limitation, I have to stop. But this is exactly what we are going into tomorrow's workshop that I'm having on Industry 4.0. So these are the two questions that we will jump into, but we will also go back to the very brief discussion that we had until now to deep dive into it, so to understand a little bit better, is the consumer the only driver here, or is there a little bit more? Well, digital tools, we saw a little bit, but how do they assemble to higher order solutions? That's what we are going into tomorrow. All right, so for those ones who I do not see at tomorrow's workshop, I would leave you with these three, we'll call it statements that I made here. First one is that we, as the consumers, so all of us, that we are actually a key driver of Industry 4.0. And that's for me also the strongest argument why there is no alternative or no way out. We are driving it. And the other side is a reaction side. That's not the driver side. Secondly, Industry 4.0 sooner or later creates a created system. That's the nature of this digital technology dropping in. You connect everything, and then you look at it as a system. All its implications on the employees, on the leadership, and also on how to operate it. And the last message, and this is the most important one, and also this we heard again or already today, technology always has to serve the system, not the way around. Or in other famous words, you should never ask what you can do for technology, you should always ask what the technology can do for you. And that should conclude my presentation. Thanks.